Hello everybody! Welcome to Stop Confusion Animations. My name is Sarah, and we're covering the 5 most confused psych terms, starting with Gestalt Principles. So before we get into the thick of things, we kind of have to ask ourselves, well, what are they? The Gestalt Principles started off as a theory used to explain how we perceive certain patterns, and why we don't perceive other certain patterns. Okay, so that might sound complicated, but basically, it just focuses on how our brain likes to group things together or separate them. Alright, so let's start off with proximity. The great part about this principle is, it means exactly how it sounds. When things are located near each other in a certain way, you see them in a certain way. So for simplicity's sake, we're mostly going to be using geometry to make things easy. Take this set of boxes, for example. But look closely at the way they're spaced. When there's equal spacing between all the boxes, it's ambiguous. You don't really perceive much other than a big box full of smaller boxes. But if we add vertical spacing, you see columns. And if we add horizontal spacing, you see rows. It's important to remember, though, that in proximity, all of the shapes do not have to be the same. Take this owl, for instance. It's not really an owl. It's really just made of a bunch of different random objects. But you see it as an owl because of the way I've arranged them all. So, we're not done messing with your brains yet. Next up, we have similarity. And just like proximity, it means exactly what it sounds like. Stuff that looks alike is put together. But if you're just putting things together again, what's the difference between proximity and similarity? Well, in similarity, all of the objects involved are the same, unlike proximity, where the objects can be different. Take these patterns, for instance. In one portion, there's one pattern, and the other, there's another pattern. But because of similarity, you can pick out the pie piece with no trouble. This is really where we start to see how the principles interact with each other. In this case, proximity and similarity are both working together to show you a circle with a piece of pie cut out of it, instead of just a bunch of random shapes all kind of clustered together. Let's take a look at that owl again, but with similarity applied to it. This time, it's made of circles, but you still see the owl. Next up, we have common fate, which might sound a little misleading, but basically means that things that seem to move together are grouped together in our minds. The best way to probably visualize it is by thinking about a flock of birds, or a school of fish. Together, they look like one solid mass, but really they're made up of a bunch of individuals. So movement is key in this principle, because at rest, these objects may not seem to have any correlation. They may just seem like a bunch of random points, or a bunch of random fish. Again, you can kind of see here how proximity and similarity play into this principle. As we're starting to see, your brain likes to make things easy for itself. It likes to put things together, and in good continuation, it likes to see flowing things rather than sharp angles. If continuity is possible, like in these flowing lines that overlap each other, you're likely to see it first, rather than these strange curvy angles. You might oftentimes see this used in advertising. Something like this whoosh, for example. The continuity leads your eye through the letters to the flying object. And while your eyes might wander, you're always drawn back to the object because of the continuation. This next one is a personal favorite of mine, called closure. Now this one is cool, because you don't need a whole image to tell what the picture is. Your brain fills in the rest for you. For instance, take these circles. You see the square, but you're looking at a bunch of circles with pie cut out of them. And you see it because your brain doesn't need it to be complete. It recognizes the shape without it being all there. This principle is really fun for playing with monochromatic. Like this penguin, for example. It should just be a bunch of black blobs on a white background. But because of closure, you see the penguin. Most of you will probably recognize this one, since it's most often seen in optical illusions. Relativity is the relationship between one type of space and another, and figure ground is our ability to differentiate the figure from the background. Let's explore relativity here a little bit first. It has very much to do with area. The smaller area is usually seen as the figure against the larger area, which is the background. Pretty straightforward, right? You can really see this in the first figure. This idea is reinforced if you have the larger area bordering the smaller area on all sides, as in figure 2. The cool thing, though, is that you can trick your brain into seeing the larger area as the figure against the smaller background, as in figure 3, but only if you line up the larger area on the x and y axes. Now, I suspect that most of you probably recognize this example. The two faces, which can alternatively be seen as a vase, and depending on which area is the lighter or the darker portion, you see something different first. Symmetry is especially prominent in this principle. People love symmetry. Our brains just, it feels right, you know? But anyways, let's look at a real-life example. Like the FedEx logo. The designers of the logo rearranged the letter E just slightly so you'd see an arrow. So last, but certainly not least, is the law of Prägnanz. It seems a little bit complex, but really it's just our brain's way of being cognitive misers. People don't like to think, so naturally we want to see the most simple and stable shape possible. In other words, we like to make things easy for ourselves. We don't like stuff that's hard to think about. So for example, if you see 4 dots, you're gonna see a square, not a cross first. You might see the cross after, but that takes more thought. This is also the case with more complex shapes, like the one below. You've got a bunch of funky angles and spaces and corners, but your brain immediately jumps to 3 interlocking squares. This principle also explains why when you see this shape, you don't see a bunch of circles with bites cut out of them and leaf shapes. You see 5 interlocking rings, or even the Olympic rings, because that's the most stable shape, a circle. Thank you so much for watching, everybody, and I will see you next time with another Stop Confusion short.